all very much for coming out. I just want to start out with perhaps a common misconception, although perhaps less so with this crowd, that robots in the workplace have to be, as you put it earlier, androids, that we're directly replacing a worker that's like, well, we're going to replace the guy doing this with a robot that's doing this. But obviously that's not the case, and you three all have been working on very different systems over the years and have worked in many different companies and universities and projects. Can you tell me a little bit about how you envision the collaborative robotics space as opposed to the android space?
Well, I think, when we set about looking at robotics in the warehousing space, a lot of it has to do with taking away a lot of the low-hanging fruit, and a lot of the easier tasks, things like walking, things like finding the item, things like figuring out where the item goes. And a lot of that doesn't require an android to be walking around in a warehouse. A lot of that just requires simplifying the work for a human, and that's really what we focus on. So, ultimately, maybe in 15 years, people won't be running around in warehouses. They'll be finding better things to do with their time. But for a long time, there will be opportunities for collaborative robotics to work and really assist humans. And there's a lot of things, again, you can do to make a human 2 or 3 times faster, more productive in a warehouse without having to replace the human. And that's really our philosophy.
So spent a lot of time looking at how people and robots work together, and some of the latest work towards collaborative robotics that we're doing is using exoskeletons. So how can people wear a robot to help them be safer in their environment? So, have better ergonomics in their movement, take weight of tools off of their hands, allow them to work longer shifts. And some of the work we're looking at there is in nuclear environments. So it's already work where people are in big suits, they're in respirators, and how can we take some of that effort off of them?
You might even call that symbiotic robotics, if it's like it was something you're actually wearing on your body.
Exactly.
Yeah, I think there is sometimes a misconception that automation is all about sort of a direct line march from all people to all robots, and that really in many ways humans and robots have very complementary strengths. That robots can be fast, they can be strong, they can be precise and repeatable, but humans have flexibility and dexterity and judgment and intelligence that are really way beyond the capabilities of
It wasn't me.
of robots in the foreseeable future, and that a huge amount of value can be created by allowing those two very different elements to be combined in different ways, and that's really what a lot of manufacturers and logistics facilities, that's what people are looking for. That people are looking for robotic solutions are often looking for ways that robots and people can work together.
Right. With the robots are the chocolate and humans are the peanut butter. That's right.
Yeah, exactly.
But so obviously this collaborative robotics represents a major step forward in labor and in manufacturing sort of technology in general and the techniques involved. But we have to move forward carefully, for safety reasons, for ethical reasons, for economic reasons. Yep. How do we coordinate that effort? Do we need some kind of federal robotics commission to guide these efforts? Do we need some big centralized thing, or is that a big mistake? Or somewhere in between, obviously.
I think you have to also look at the scale of collaboration, right? So, some of the work that Clara is working on and that Holly are working on, the repercussions of something going wrong are pretty significant in that case. But, I think in a lot of places, there are already beginnings of OSHA standards and ANSI standards that are being developed around, whether you call them AGVs or collaborative robotics in our case, or whatever it may be, that actually are a pretty good guideline, right? And I think from there, it's up to the technology companies to kind of develop and innovate around that, because I don't think the government is going to be on the leading edge of a lot of these things from an industrial perspective, right? I think companies have to understand there has to be a payback for some of these solutions, right? So you can't bolt on a bunch of additional costs for a system just to make it safety rated. But I think there's wonderful innovations that are already in place today. If you look at the capability of the sensors that we have available today and the price point of those sensors, you can make a robot much more safe to work with and a much more intimate relationship than you did 5 years ago, right? And there's still an economic motivation to do that. So.
Yeah, there in fact are already international robotic safety standards organizations that are actually quite active and quite sophisticated, and we've actually, we are a part of those committees, and what they're really focusing on now is modifying the international safety standards to accommodate collaborative robotics. That's one of the big focuses of the new rewrite of ISO 10218. And customers in this area, and quite rightly so, they look for compliance with these standards because those are their ways of making sure that the systems that they're deploying are not going to harm their workers. And people are very committed to that. And that's a good thing because it lays out a roadmap for here's what we have to do. Although of course, like I said, those standards are being modernized to accommodate new advances in robotics. It is a challenge. It's a big responsibility. That's something that. If you're not thinking about those things, if you're not ready for that, it's going to be challenging because you do have a responsibility to do it right. And that's why we have, from the beginning, we joined the committees. We've been working with the regulatory agencies that do this. We're running a 61508 compliant process because, there is a lot of innovation, but, it is, an important thing to be really doing right.
And there was just a vote a couple weeks ago to start a wearable robotics or exoskeleton committee with ASTM. So they're picking that up as well.
Yeah, and there's a mobile, most of the committees have been focused on sort of the standard industrial arms, but they're now developing a mobile standard as well.
Where do you think these where are strong rules actually needed, and where do you need leniency if you're going to have flexibility for deploying and for developing stuff? But where are there strong rules where somebody needs to say, no, we really need to make sure that this is the case when we're deploying this stuff?
I think one of the challenges, you can't, the regulations and the standards have to follow the technology development. You can't develop formal hardline standards for things that people haven't invented yet. Mm-hmm. So I think it's a bit of a dance between innovators coming up with new things, new ways to do things, and like you were saying, the sensing and computing and all the capabilities there that just didn't exist before, and we're going to use that. But having hard and fast rules for those things at this stage, when we're really just learning, is a challenge.
I think also, there are some very well ergonomic standards for people that do repetitive tasks and those types of things. Or in our case, the amount of weight that you can lift over at different areas of the strike zone of a person, as an example. Those are things that are, Europe has been in the forefront of that for a very long time. It's starting to come to the United States because we do want operators to be comfortable in their job. And that's the point of having that robot there to begin with, right? That in our case, our mobile platform is there to really eliminate a lot of the walking and try to make it easier for that operator to do their work. So things, again, the weight, the number of times the task is completed, those are the types of things that I think are very well suited towards implementing in technology and having some regulations around and are very well understood. So,
we talked about the chocolate and the peanut butter, but one of the sort of ways that we do not complement each other is that humans and robots don't really speak the same language. There's a communication gap.
Sure.
And robots, of course, have become very good at sensing their environments, and especially VO is very good at setting up that awareness of a space, things like that. But that awareness is different from actual communication. How do we close that gap? Because people have to communicate. If you're going to be in a workplace, you have to be able to communicate with your coworkers. Mm-hmm. And if your coworker is a robot with sort of elementary natural language processing, but really good spatial detection, like how does that help? What is the next step with that? Like, what are we working on?
So I think we're especially excited about that because I think what we've done is we've taken a platform and we've designed it around something that most people understand very easily, which is a car. And we said, okay, in a car, you understand the behavior of that car when the lights are flashing on one side, so you use blinkers, that kind of thing. In a car, you also understand the concept of a GPS and following that around. So having a mobile robot actually lead an operator through and telling the operator where they're going to go next and what they need to do next is actually a very normal, logical thing. And that's one of the big advantages I think we see in our platform. We've also brought in some experts in the field of education. One of our co-founders, a number of our technology people, were working in the education space. So disseminating complex information into a way that can be communicated effectively for an operator that may or may not have a high school degree is something that's very, very important for us, and actually is a key to our adoption of our technology in these warehouses. If you're trying to replace a little screen half the size of most people's smartphone with a bunch of text on it, you want to do that, which is what they typically use today. You want to do that in as easy a way as possible for people to digest that information, improves the adoption, reduces training, all those types of things. So we spent a tremendous amount of time in the design of our software and our hardware to facilitate that.
In my lab, we've been looking at ways to communicate imminent robot failures to bystanders or to people that are working with them on the manufacturing floor. And just looking at things as simple as icons. Could you see an icon on a robot and know that this robot is not one that you should walk by right now? You should stay away from it right now. And it may not be failing, it may be working, but it's doing something that you should not be engaging with it at the moment.
Yeah, and of course, visual communication is much faster, and because human spoken communication, even to a large group of people, is a very low bit rate, as it turns out.
Well, and trying to use any sort of sound in a manufacturing environment may not work at all.
Yeah. In addition, I think spoken interface can, in some ways, overpromise on intelligence.
Oh, yeah.
You know, if you have the robots talking, then you have this theory that it can, understand things at the level that a human does. And one of the things, and Jerome, you mentioned this, that I think is really critical, is for an operator to be able to form an accurate mental model of how the system works, so that the system behaves predictably, so that the operator can correctly judge what it's going to do if I do this.
Yep.
And then, interface. I mean, I think there's a lot that, and this is true, I think in industry outside of robotics as well, that there's been a lot of innovation in the field of human-computer interface in consumer in particular, that you can then take those concepts and apply them to an industrial setting, and the same principles of sort of good user interface design, and combine that with then designing the robotic system so that it is predictable and understandable. And those two elements, I think, are.
And just one last note on that. I think also in our space, where we're dealing with an operator doing thousands of the same transaction during an 8-hour shift, things that make it exciting for that operator is really important. So gamifying the user interface, right? Adding some Candy Crush elements to the UI so that, hey, on the 1,000th pick, they get a gold star, or whatever it is. I think that really also motivates people, because a big problem in this space, and I hope we talk about it in the panel, is the retention of skilled labor is incredibly expensive for these companies. So to make something easy to work with and also fun to work with is a big piece of what we can bring to the table.
So I'm curious how you decide when technology is good enough to use. Like, when does it reach a point when you can say, okay, we can use that in an industrial setting, it's reliable enough that we can build a system around it. For instance, the depth cameras that you guys use in your prototypes were consumer models or Connects. But, did you see that a few years ago? Like, well, that's good enough for us to start testing with, and we can move on later. Or things with, actuators, like having a certain amount of control, and so you can stop within this tolerance or whatever. Like, how do you decide when a technology is good enough to deploy in a mixed workplace?
Yeah, I mean, I think that you bring up the question of sensors, and that is absolutely central to what we're doing. And a couple of the speakers earlier referenced the sort of industrial needs for precision and reliability. And this idea of having an industrial robot know where people are and react appropriately has been around for a really long time. But until recently, I think the sensing technologies just weren't there. And there's a lot of work that people do to pull 3D information out of 2D images. And the chance that those kind of techniques would get to the 100% reliability that you need for an application like this, it just wasn't there.
Yeah.
So when we started seeing, in fact, that's one of my co-founder, Patrick Silbovaro, he'd been looking at this space for a long time, and when he saw that time of flight depth cameras were starting to become readily available, that was really one of the changes that we said, okay, now we can do this. We can see where things are, and you can do things like use redundancy of sensing elements to say that, that's one of the key things in functional safety standards, is that a single hardware fault, single fault tolerance can't cause a safety failure. But you can use redundant sensing elements to build a system that is safe using those kinds of technology.
So one of the things I do is spend a lot of time thinking about how to break robots, which I know
no
sounds
kidding.
horrible. But I have a 10,000 square foot robot testing center, and one of the things that
Must
we
be
do
nice.
is, yeah, it is, it's pretty nice, is think about manufacturing robots and rolling around or the pick and place. What happens when somebody decides to put something or something falls where it shouldn't be? So we are developing ways to test those robots at those centers, and one of the things we're playing with now is even negative obstacles. So if there's well, you don't usually get sinkholes in the middle of your manufacturing floor, I guess, unless you're in Florida. It could happen. Or you're near a staircase, or you've mismapped and you're somewhere
Yeah.
you shouldn't be. What happens, and how do those robots react to that? So we're really trying to look at those boundary cases to the autonomy, and how can we test those fully?
I think, for us, and it's really been also a big shout out to the open source community too. I think, if you look at the cost of sensors, that's one thing, and we look at 3 technology trends that really are enabling us to be able to do what we do. So we look at, the miniaturization, cost of sensors, et cetera, but also open source and cloud computing. And when you look at open source, you now have this wonderful environment of developers, incredibly brilliant people that are writing this code and developing this code for, may or may not be commercial purposes, but the commercial community, the business community can pick up on that and start leveraging that and obviously contribute back to it. And when we look at it, we say, well, how many times has this line of code been used out in industry? Who else is using this as a way of validating that, hey, this piece of code using the SICK LiDAR has been well established as a baseline, for dozens of companies. Let's go ahead and jump on that, because that also reduces our cost of development, right? So that's a huge benefit for us. So.
Yeah. And I think what you're touching on as well, so the sensing is one critical element, but also then on the flip side, computing.
Yeah.
Especially in 3D, you're just talking about tons of data.
Yep.
And again, GPUs, when you're trying to process all this point clouds from multiple cameras simultaneously in real time, we're running on a NVIDIA GTX 950, and I'm sure you guys everybody's sort of looking at the computing power that you need to be able to process these new kinds of data, and do that right away, which is also critical for an application like this.
And before you can have all these interesting problems, you need to actually automate a workplace. And of course, that's still in the cards for a lot of businesses out there, a lot of industries. But it's a different play now than it was 10 years ago or 5 years ago even. How does the pitch differ? Like, how does it differ now than it did a decade ago, when you're talking to a company and saying, well, here's the benefits of adding robots to your workplace, here's the costs, here's the regulatory issues. How does that look now versus 10 years ago, 15 years ago, or just last year even?
I think, so in the case of warehouses, clearly the case study there is Kiva Systems. And, a number of us had a good fortune of working in that company and for that company for a number of years. And what we did there was transform an industry in understanding that mobile robotics can be used in a very industrial place like a warehouse. Now, believe it or not, Kiva hasn't been available for 5 years, and the landscape hasn't changed much to our benefit and to the benefit of others. But we look at it and we say 70% of the warehouses in the United States actually aren't highly automated at all. So that's a wonderful opportunity for automation to be introduced in that space. And in addition to that, people are a lot more educated about what's available out there. I mean, you saw a company back that was created in 2003, got its first commercial customer in 2006. That was 11 years ago. That technology landscape has changed significantly. In fact, completely redone a number of times over since then. But people have gotten smarter about technology. People have gotten, classic example, cloud computing. We talked about it. The tried and true solution for software in the warehouse environment is having a server rack sitting in a corner of a warehouse somewhere with an enterprise software package. Now, most people, all of our customers, use WMS on the cloud or use our system on the cloud. Would have been unheard of 2 or 3 years ago. Yeah. And now we're seeing rapid adoption of that space. So again, all really good things, and they understand the benefit of that. They understand at the end of the day, these things are measured in ROI and payback, and that helps their payback for these solutions.
Yeah, you can put that right in the brochure, like, now you don't need to install your little server cube.
Absolutely, yep, exactly. So.
Yeah, I think we're seeing a lot of pull as well. So I was just at a workshop on industrial exoskeletons a couple weeks ago, and you saw a lot of major car manufacturers there. Harley Davidson was there looking for how can we help our employees on the line, and how can we get things off of a lift and make it something that they can be lifting themselves, the exoskeleton, and allow their manufacturing floor to be more flexible. So there's actually quite a bit of pull as well.
Yeah, I think we see that absolutely as well. That, I mean, manufacturing is actually that has been fairly automated for a long time.
Right.
But so, we have manufacturing engineers, people who develop work cells for, building cars, building refrigerators, they're engineers, and this is what they do all the time. I mean, in fact, most factories will actually have a tool room for building custom machinery to automate all kinds of different things. And so they're always looking for solutions. And I think the first generation of collaborative robots, the sort of smaller, lightweight collaborative robots that really introduced that concept that you can have a person and a robot working together, that really opened a lot of people's eyes. So people are out there looking for ways to do what we're doing. There is a lot of pull. And then I think there are some areas, and I think logistics has been less automated than manufacturing. And in that case, a lot of the barrier has been that, if you want to automate one little aspect of the process, you have to automate the whole thing, because that's the way it was before. And now to be able to say, no, you don't have to, completely reflow your entire line. You don't have to build a totally new facility. You can just put robots into your existing facility in the places where it makes sense. That actually makes it a lot easier for people to start adopting this kind of technology.
I think that's a great point, Clara. I think that what we found is in the past, robotics meant retrofit.
Yeah.
Right.
You had to tear out everything and start over and fresh. Now, because of what we talked about, these technology trends, you can actually just go ahead, zero infrastructure nearly, get a Wi-Fi signal up in a building, which is pretty cheap and pretty easy to do, and off you go, right?
Yeah.
And that actually is what has a major change in the landscape.
Yeah.
A major reduction in the risk and the outlay that you need to do
Absolutely.
at the very front end.
And it opens it up so that a lot, the available market, the addressable market now is much more significant, right?
I was going to ask, because it lowers the floor for entry,
That's
and that opens it up for so many new industries. Have you guys seen any, or are interested in developing for any particular industries where you're like, oh, I'd love for a home artisan woodworker to be using my exoskeleton or something like that? I imagine it's exciting that.
As part of the ARM Institute, so the Advanced Robotics for Manufacturing Institute, which is headquartered in Pittsburgh, we're just starting to survey a lot of the small and medium enterprises to see what are the types of robots that they would want to see, so that not all robots are being developed for Boeing or for BMW, and what is it that those small shops need. So we're starting to do a lot of that work right now.
And I think consistent with that, the other thing that is impacting manufacturing is, mass customization. So even for a large manufacturer, they may be looking at making a lot more of a lot different things, and that requires a level of flexibility and agility. And the most flexible resource available on a manufacturing floor is a person, because they're always going to be able, learn, do one thing in the morning, do something else in the afternoon, and really flexible. And I think that that's another reason why manufacturers are looking to have people and robots working together. And I think that in some ways brings the needs of the large manufacturers closer to the needs of the small artisan manufacturers.
This is kind of a complex topic to bring up in the last couple of minutes, and also may fall under the sort of not my department area.
We can handle it.
But what do you think? What is our responsibility as people who are in this industry, but not necessarily like a large company automating their workforce? What is our responsibility as a society as far as retraining, preparing for major workforce changes like layoffs and huge, efficiency gains of course that's on the high level, not on the factory floor. Like, what is our responsibility as a society and as companies that have to address this?
So I think, if you look at the warehouse industry, where you have sometimes companies are going, what they call a 10-to-1 peak to mean. They have to hire 10 times as many people in the building for 8 weeks a year as they do for the average year or average part of the year. It's almost impossible for people to find enough labor to do that. And in fact, there is a dramatic labor shortage in that space. So what we're allowing companies to do now is actually make it easier, lower the requirement for people to be able to get into these buildings, because the job is actually that much easier to do. So you've opened up the available labor pool for these companies, and now what you're allowing for is people to actually come in and get good jobs, because these are actually good paying jobs, working in buildings and starting building salary and improving their skill set. So we feel very strongly about the types of things that we're trying to enable here. Again, there's a shortage of people that are able to do this, so we're trying to actually make it more available and a wider pool of people to be able to do it. So.
Yeah, I mean, I think that so what you're saying is it's not necessarily the case that you're taking a job that was done by a person and doing it with a robot. In some cases, in fact, you're taking a job that was done by a robot and doing it with a person. But I think that in general, I mean, one important thing to remember is that this isn't a new problem because we use the word robot. Robot sounds real high tech and scientific, but this is the replacement, increases in productivity, shifting the labor pool. This is the same thing with the knitting machine and the combine and the backhoe and computers. And I think that what we've seen, in the long run in history is that improved productivity is good for us as a society. Yeah. That said, that doesn't mean that there aren't definitely specific negative consequences. People do lose their jobs, and that can be devastating, of course. And I think the point that you made is that as a society, we do need to figure out how to handle this. That whether you're losing your job because of a robot or because of a machine learning algorithm or because of an internet delivery service, technology changes very fast and getting faster, and we need to be able to help people that are negatively affected by those changes. And that's something that we're not doing very well as a society right now, and that we need to be doing better.
We're developing something we're calling the arm farm, which is going to be used to test a lot of algorithms on robot arms, but we also want it to be used for worker retraining. So either they can come in and use it on our site, but we're also developing the ability to use the robots remotely. So we are starting to think actively about worker retraining, particularly here in the state of Massachusetts, but hopefully it will go beyond that.
Great. Yeah, so not a new problem, but hopefully we have some new solutions. All right, well, thanks for joining us, and I guess we'll just exit stage right now.